In 2017, a team of researchers gave a machine one job: learn the rules of the oldest board game still played today. No data, no human games to study, no coaching, just the rules. 3 days later, that machine had become better than every human who had ever played, including the reigning world champion. But that's not the strange part. The strange part is what the researchers found when they finally looked at how it was actually thinking. The game was Go, not chess. Go is older, simpler to explain, and vastly harder to master. A grid, black stones, white stones. One rule about surrounding territory. That's it. And yet, the number of possible games of Go is larger than the number of atoms in the observable universe. Chess has roughly 35 possible moves at any given turn. Go has closer to 250. That difference sounds small. It isn't. It's the difference between a puzzle a computer can brute force and a puzzle that requires something closer to intuition. For decades, computer scientists considered Go a wall AI simply could not climb. Chess had fallen to machines back in 1997. Go experts confidently predicted it would hold out for another 30 years, maybe longer. Some said it might never fall at all. It didn't hold. In March 2016, a program called AlphaGo, built by a London lab called DeepMind, beat the reigning world champion Lee Sedol 4 games to 1. And in Game 2, it played a move that broke the room. Move 37. Commentators went silent on the live broadcast. Lee Sedol got up from the table and left the room for several minutes. The move made no sense by any standard of human strategy built over roughly 2,500 years of the game's recorded history. Professional players in the commentary booth called it a mistake in real time. It turned out to be brilliant. The match for anyone to understand what it had actually accomplished. But here's the detail almost nobody remembers about that version of AlphaGo. It had studied millions of human games first. Professional matches, amateur matches, decades of recorded play, all fed into it before it ever touched a real opponent. It learned by watching us. In a very real sense, it was still ours, a reflection of everything human players had already discovered, sharpened, and recombined. The team wasn't satisfied with that. If the machine had to study humanity first to become superhuman, was it really demonstrating intelligence? Or was it just very good mimicry with extra computational steps bolted on? So the researchers, led by a scientist named David Silver, built something new. They called it AlphaGo Zero. And this time, they took away everything. No professional games, no opening strategies, no historical database of centuries of accumulated human theory. They gave the system a board, the rules, and nothing else. It started by playing itself, over and over, at incomprehensible speed, randomly, at first, placing stones with no understanding of why one move was better than another, losing to itself, over and over, learning almost nothing for the first stretch. For those first few hours, it played like a confused child mashing pieces onto a board with no plan at all. There was a mechanism underneath that chaos, though. Every time the system won a game against itself, that outcome got fed back into it as a signal, a kind of digital reward. Every loss did the opposite. Multiply that by millions of games, run in parallel, day and night, and a strange kind of pressure builds. Not understanding, not in any way a person would recognize it, just an enormous number of tiny adjustments, each one nudging the system a fraction closer toward whatever had worked before. No teacher, no curriculum, just relentless, repeated consequence. Then something changed. By around day 3, AlphaGo Zero was placed against the earlier version of AlphaGo, the one that had beaten Lee Sedol the year before, the one trained on human data, the one that had made the entire world stop and watch a machine outhink a grandmaster. AlphaGo Zero won, not narrowly. It won every single game. 100 games played, 100 games won, 0 losses. A system with 0 human knowledge had, in 72 hours, surpassed a machine that took years to build using our entire recorded history of the game. And it kept going. By day 21, it had caught up to and passed AlphaGo Master. the most advanced version DeepMind had ever trained up to that point. A version that had already defeated the top-ranked human players on Earth in online matches. By day 40, according to the paper the team published in the journal Nature in October 2017, AlphaGo Zero had exceeded every prior version of itself combined. 40 days, zero human instruction, a superhuman result in a game humanity had spent thousands of years refining. Here's where it gets strange. In the very first hours of self-play, researchers watched AlphaGo Zero independently rediscover openings and patterns that professional human players had spent centuries developing and formalizing into something close to doctrine. It found Joseki, the standard opening sequences taught to every serious Go student, entirely on its own, just by playing itself over and over with no instruction. It reinvented, in a matter of hours, ideas it took our species roughly 1,000 years to arrive at and agree upon. But then it kept playing past that point, and it started abandoning those same patterns entirely. It moved beyond the openings humans consider foundational, and began favoring different sequences, moves that appeared nowhere in any historical record, strategies that professional players still study today, trying to understand why they work. Not because the machine can explain its own reasoning. It can't. It has no language for what it's doing, no internal narrative to hand back to the researchers who built it. They can see what move it makes. They cannot fully see why, only that across millions of self-played games, that specific move statistically wins more often than any human ever found. This is the part almost nobody talks about when the story gets told. It's not just that a machine got very good at a board game. It's that a system trained on nothing but its own experience independently walked the same intellectual path human civilization took over roughly 1,000 years, compressed that walk into about 3 hours, and then kept walking straight past the edge of our map. Everything after that point exists inside a kind of knowledge that no human being put there and no human being fully understands. Top Go professionals now study its games the way earlier generations studied ancient religious texts, trying to reverse engineer wisdom from something that cannot tell them what it knows, or why it knows it. And this wasn't a one-off trick confined to a board game. The same lab, using the same underlying self-play approach, was pointed 2 years later at a problem that had stumped biologists for roughly 50 years, predicting how proteins fold into their three-dimensional shapes. A problem central to understanding disease and designing new medicine. That system, AlphaFold, produced predictions accurate enough to reshape how biological research is conducted globally, again by learning patterns no textbook or database had ever contained. The pattern from that quiet lab in London kept repeating, again and again, in field after field. Give a system almost nothing but the rules of a problem. Let it play against itself millions of times without rest, and it will find solutions faster than the accumulated output of human civilization managed across generations. That's the uncomfortable part sitting underneath the board game story. We built a method that doesn't need us. It doesn't need our games, our textbooks, our accumulated centuries of trial and error passed down teacher to student. It can, in certain narrow domains, rebuild everything we know from scratch and then continue past it within days. We spent roughly 1,000 years arriving at Go theory as a species. It spent 3 hours arriving at the same place, and 3 more days leaving all of it behind entirely, without once looking back. The researchers who built it never claimed to fully understand everything it had found. They could measure that it worked, game after game, with numbers that didn't lie. They could not always explain why a given move worked, only that it did. Somewhere in that gap, between a result you can verify and a reasoning you cannot access, is a genuinely new kind of unknown, one that has nothing to do with science fiction and everything to do with a small team in a London office who gave a machine only the rules of an ancient game, and then sat in silence, watching a screen, as it quietly worked out everything else entirely on its own.